Okay, so Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. So this is the first chapter, number system. So in number system, we actually have 3 subtopics. So the first one is the real numbers, and then the complex numbers, and then the indices, surd, and logarithm. So today we are going to learn about the real numbers. So let me click to the real numbers. Okay, so the real numbers, we are going to start with the smallest set of numbers, which is the natural numbers. So by definition, natural numbers is actually accounting numbers. It starts from 1 onwards. So we start from 1, 2, 3, 4, 5, 6, 7, and so on. So those are actually the smallest set of numbers, which is the natural numbers. And then we're gonna extend it a little bit. So what do we get is actually a whole numbers. So the whole numbers is either accounting numbers or zero. So that means if you take your natural number previously and then you simply add with one number that is zero, and then you're gonna get the whole number. So whole number is 0, 1, 2, 3, 4, 5, 6, 7, and so on. So those are the whole number. And in fact, if you look at the diagram over there, you should be able to see that this natural number is actually inside the whole number. So that is why we can actually write them down as n is a subset of the whole number. So natural number is actually a subset of the whole number. And of course, the whole number is not the biggest set ever. So we can actually make it a little bit bigger. So extend a little bit. Therefore, we're gonna get an integer. So integers is either a whole numbers or it's negative. So we can have -1, -2, -3, -4, and so on. And you can have 0, 1, 2, 3, 4, and 5. So all those things are called integers. And in fact, if you look at over here, this is called the negative integers. So sometimes we do note them as z with negative, and this one is normally z with a positive, just simply to take note that this is a positive integer, that is a negative integer. And then as you can see, n is inside the whole number, but now the whole number is actually inside the integers. So that is why we can say that n inside the whole numbers inside the z. So this one normally we're gonna call them a subset. So natural number is a subset of the whole number, is a subset of the integer. Okay, so of course we can extend it a little bit bigger, where we can have irrational numbers. So irrational numbers is a number that can be written as a ratio of 2 integers. So you can write them down as p over q, where both p and q will be integers. So we have learned about integers previously. So as long as we can write them down in the form of p over q, then those things are actually rational numbers. So as you can see over here, 1 is an integer, 2 is also an integer, so therefore this is a rational numbers. 11 over 9, 11 is an integer, 9 is also an integer, therefore this is also a rational numbers. Okay, so for these two, both of them are actually decimal numbers, so let us refer to over here. For decimal numbers, it can be a rational number if its digits are terminating or repeating. So what do we mean by its digits are terminating? It means that it will stop after a few decimal places. So for example, over here, 0.777777. So it stopped after 6 decimal places. So this is called a terminating. So another example for this might be 0.1. So this one might be the similest thing that you know, 0.1, or perhaps 0.5. That also stop after 1 decimal places. So as long as the numbers stop after a few decimal places, we're gonna call them as rational numbers. Another one is repeating. Repeating means we keep on repeating the same number. For example, 0.23, as long as you can see a bar on top of the 23, it simply means that we're gonna keep on repeating 23 until infinitely many, of course. So 0.23, 23, 23, and so on. So if you don't want to write them down as a bar, we can also use a dot on top of them. So 0.23 dot dot. It simply means the same thing. So as long as we can repeat the same digit, or we can stop the number after a few decimal places, those are called as rational numbers. And then as you can see again, so n is inside the whole number. The whole number is inside the integer, and then we extend it a little bit into irrational numbers. So we can say that n is a subset of the whole number, is a subset of an integer, and integer is a subset of irrational numbers. Of course, if we have something with irrational, we do have something with irrational. So that is actually the opposite of rational numbers. As you can see, if rational number, we got a Q, this one is a Q with a bar, it means not rational. So irrational numbers, Q bar, is a number that cannot be written as a ratio of two integers. So before this, we write them down as P over Q, where both P and Q are integer. But for irrational number, one of them is not an integer. So that is why it is an irrational number. If you want to write them down as decimal, it will be non-terminating and non-repeating as well. So we didn't repeat the same number, and we are not going to stop after a few number. As you know, square root of 5 is not an integer, so that is why we're gonna call them as irrational numbers, because this is actually not in our integers. Over here, we have pi over 2. So pi is actually not an integer. So one of them is not an integer. Therefore, this is also an irrational numbers. So E is actually a number that is non-terminating. So that is why we're going to call them as irrational numbers. This one also, this is not an integer. Therefore, this is definitely not irrational numbers. This one, you keep on writing down some numbers. Once you have the dot dot dot, it means it's keep on going until infinitely many. So that means this is non-terminating, therefore this is irrational numbers. So we have natural numbers, whole numbers, integers, rational and irrational numbers. And of course, we can conclude these rational and irrational numbers by putting them all inside a whole big set of numbers called the real numbers. So real numbers is the biggest one, and rational number combining with irrational numbers, everything is actually a real numbers. Okay, so now one question for your thought. Do you think that square root of 4 is an irrational numbers? So I'm going to put a link in our Google Classroom, and I want you to write down your thought for this. Do you think that square root of 4 is an irrational number? So I'll see you guys in the next video. Bye.